Here we go, we've got water flowing in. Hello there everybody, Sam's Trains here, welcome back to the railway, and I hope you're ready for another crazy experiment today. So a little while ago I got a comment from a user called I Like Transport, there we go, and he said, can you try a model locomotive underwater, or words to that effect. Now when I read that comment I just thought, you know, that's too silly, that's never going to work, I don't think I'm going to try that. However, the more I thought about it, the more I decided this is something that's got to be done. So I'm going to try it today. Goodness knows what's going to happen. It may not work at all, but I think we ought to at least try it and see what happens. So the test subject, or at least the victim, as it's now going to be known, is this little Southern 040. Now this little engine has already proved itself quite nicely because it's run on more than twice the voltage it was designed for without breaking down. So this is going to be our little test subject today. This is the loco that's going to be submerged in water, and we're going to try it and see if it works. Now before I show you the experiment, I just want to talk a little bit about safety. Now contrary to what you might have heard, water and electricity do indeed mix, and in fact that's what makes it so dangerous. However, the 12 volts or so that we're going to be using these models on isn't all that dangerous. In fact, I'm going to be putting my hands into it and there's nothing going to happen to me. However, just having a body of water in the vicinity of electrical devices is a bit dangerous. Obviously, if you have a spillage, you could have a bit of a dangerous situation there. So by all means, if you really must try this, do try it at home, but use a 9-volt battery as your power supply. That way you haven't got to have electrical appliances around. Second of all, it's very, very possible that this model will work just fine underwater. However, that doesn't mean that you should, you know, take your models into the bath and play with them underwater, especially if they're precious to you, because of course once you take them out of the water, the metal parts are going to start corroding, you're going to get rust, and you're going to cause problems. So as I say, try this at home if you want to, but expect to lose the model, if not straight away, then after a few weeks or a few days, because the corrosion is going to damage them. So let's try this. There's no reason, as far as I can think, why a low-powered DC motor, at least low-voltage DC motor, won't be able to work underwater, because the voltage shouldn't be high enough to cause a lot of conductivity through the water. But of course with this we're not just talking about a 12-volt DC motor, we're talking about wheels that have got to pick up power from the track, we're talking about pickups which have got to pick up power from the wheels, and then there's all the mechanical element of this with the worm gear and the wheels and things. I don't really know what's going to happen, so let me show you the experiment and we will find out. This is going to be fun. Alright, so here's the setup. So right here is the tank, or the lunchbox if we're going to use the proper word. We've got the loco set up on the rolling road here. Yes, it's not going to be running around on a track right now, although if this does work, maybe in the summer I'll try and get an inflatable pool of some sort and we'll set up a full layout and try that underwater. But yeah, this is just a proof of concept. So here we have amps. This is going to be amps on here. So basically the higher the number on here, the more power this is drawing and the harder it's having to work. If this number goes down at any point, that means that less power is going through the loco, or it's not having to work as hard. So that also could be caused by a bad connection or something like that. So I've thought long and hard about how I'm going to actually do this. What I'm going to do, I think, is start it up first. I'm going to have the loco running, and then we're going to slowly pump small amounts of water in. So I've got a pipe here which I'm going to use to pump water in. We'll start by just pumping water so that it's above the level of the track, just to see if the track still conducts with water. Then we'll move it up a little bit further to the wheels to see if the wheels still pick up and the pickups still work. And then we'll go the whole hog and fill it right up over the level of the loco. Now it might just float away, which wouldn't be great. I don't think it will though, because there are gaps quite high up on the bodywork, so I think most of the air can escape. But if it does just float away, we might have to add some weights or maybe drill a hole in the top of the chimney. So I'm going to set this camera up so that you can see the loco and the ammeter nice and clearly, and we'll give this a try, shall we, and see what happens. Okay, shall we give this a try then? Once again, feel a bit nervous about doing this, so I'm going to set this up to about 6 volts. We'll see if it gets any quieter once it's lubricated with some water. Okay, so running with no water. We're drawing, well, it's warming up a bit, right, so about 0.15 amps, so 150 odd milliamps. That's a good rough benchmark, isn't it? Right, well, let's find out whether or not the pump works then. Let's pump in just enough water to cover the tracks. Let's see if this works. Here we go, we've got water flowing in. Looks quieter. Okay. So the tracks are submerged. What has that done? Well, we've got some rippling The current seems to have gone up a little bit, although that might not necessarily be due to the water, it might just be fluctuating naturally. But no major change there. So let's increase the water level again and see if we can't get it up towards the wheels, see if we can't cover up the wheels. Man, this is crazy. I don't know why I'm doing this, but let's try it, it's fun. Okay, pump's turned back on again. The water level should be rising. Oh, it is. It's rising faster than expected. Alright, so the wheels are now completely submerged. That's crazy. And we're still drawing a little bit more now. We're at point, well, still 160 odd milliamps, so it's gone up a little bit. Let's get a closer look at that, shall we? I've noticed that the worm drive there is in the water. It's causing a bit of frothing. And we have got an increased current now. We're at about, if I can get this in focus, about 170 milliamps. So it's having to work harder. And it's going up as we go. So let's better carry on and do this before something goes wrong. Right, we're up to 200 milliamps. I think we need to do this. We need to have a little bit more water going and do this before it dies. If it is going to die. Right, we're pumping. We are pumping. Right. We are nearly there, we're nearly over the top of the engine. This is crazy. Okay, so the motor's submerged now. And it's still working. And just the top of the cab disappearing now. And we're submerged. Let's turn off the pump. There we are. You're looking through the side of the box there. Completely submerged. Now, is it me, or is the water level dropping again? It does seem to be. Oh well, let's add some more. Yeah, I'm just a bit concerned that there might be a leak or something. Or the water might be flowing back into the tank that I'm pumping it from. I think that must be what's happening. Oh well, let's put some more back in. And what I think I might do is put my hands in the water then. Let's see if we can get any heat generated. Interesting. Is it going to kill the engine? Let's fill the water. No, just vibrating. The water is just vibrating. Right. So the voltage is dropping on the old power supply. So I'm going to turn it up now and see what happens if we thrash it. Ah, it can't handle it. The power supply, unfortunately, is not strong enough. So what we might have to do is change power supply and get something with a bit more grunt. Because this power supply is only good for 0.3 amps, and as you can see, we've exceeded that. But I want to sort of turn it right up to full speed and see what happens. So, first of all, can we start the engine from under the water? Yeah, we can. It works just fine. Right, let's change to a different controller then and see if we can put some more power through it. Okay, so now I've got one of the Hornby train set PWM controllers hooked up, so this should be able to put out an amp, I would have thought, quite easy. So let's see what happens. There we are, it's started and it's pulling about the same current as before. So now let's see what happens when we turn it up. Ooh, it's pulling an amp. Man, that isn't pulling over an amp. Ooh, that's not happy. I wonder if it's being water cooled. That motor would normally get very, very hot if it's pulling 1.2 amps. No, can't feel any heat from it, but I think it's too big a body of water for that. Wow. Well, that was very interesting. Well, let's let the water drain then, and let's see what happens once it's done so. So there we are, that's full pelt, it's drawing 1.3 amps, crikey. Yeah, that thing is under some serious strain. They pull about 0.2 amps normally, so we're talking 6 times what it's supposed to be. That's not healthy. So the water level's lowering, as you can see. We'll take some water out manually in a second, and we'll see how it works once it's out of water, see if the current goes back down again. It's running normally again now, more or less. Oh my gosh. Oh no, we've slowed back down. Ooh, 1.4 amps. Has there been a fault? It smells a bit. I can see smoke. Oh. It's busted the controller. Right, bear with me. Let's let that controller. Let's get some more of this water out. Yeah, too much current on the controller. I can see the light flashing. Maybe it wasn't designed for 1.4 amps, because don't forget those cheap Hornby train set controllers have got short circuit prevention on them. So there will be a point where the current's too much and it will consider it a short. Oops. Okay, so the water level is now well below the loco, which means it should, well, if it wasn't soaking wet, it should be able to run normally now. So let's give that another try. Yeah, it seems like it's probably dead. Yeah, it didn't like it, did it? I'm not surprised. But normally I would say it's overheated, but would it overheat in all that water? I don't know. Well, let's take it to pieces and find out. This is fascinating. We seem to have caused some sort of electrolysis on the rails there, because as you can see, only the right-hand rail has got bubbles on it, which means that some sort of gas must have been produced. Crikey, I didn't think there was enough power for that, and there's no salt in the water, so, interesting. Right, so it smells very burnt if you smell it. So I think it worked all right while the water was there, because the water kept everything cool, but as soon as we lowered the water level, you noticed that the current stayed very, very high. So obviously there was nothing to dissipate that heat, and I wonder if that was its undoing in the end. So yeah, I expect we've probably done the motor in there, but we'll have to open this up and find out. Now, this motor's already had a repair done on it, which is why I picked this loco. I think the motor's glued in place, so I might have to do a permanent disassembly on this to see whether or not we've actually done the motor in. But yeah, we'll see. Has it seized up? Right, well, I'm turning the worm, which seems to have had an odd reaction to the water, by the way, or the lubricant has, and it's still able to turn by the looks of things. So I'm going to get my power supply back, and we'll see if we can power it up directly. Right, so we are just seeing a dead short there, and I'm wiggling the worm drive, and nothing seems to be happening. I'm turning it by hand on the other side, and it seems to be very, very dead. What's the best tool for this job? Try and get it up off the chassis, and because I've glued it to the chassis, and we'll have a look and see what the state of the motor is. Yeah, no, it's still shorting. Here. That's unfortunate. Right, okay. Well, let's take the shell of the motor apart then. Right, I think we should be ready to go in. Let's take a look and see what it's done. Right. Well, there's nothing too dramatic happened in there. You won't be able to see this really, but the brushes are still intact. And it doesn't look like there's been a burnout on the commutator. So what I might try and do is restore this, and let's see if we can't get it to work again. If the windings have burnt out though, there's not going to be much I can do. Alright folks, well I think I diagnosed what was wrong with the motor. Yeah, basically the slots between the different commutator plates had completely filled up with carbon, probably due to the fact that far too much current was running through them. So I've cleaned all of that out, and it runs fine, and it's drawing a normal amount of current. So that's very, very impressive. So I'm going to put the whole loco back together, I'll glue the motor back in place, and we'll see if the thing will run again. Maybe it will. Right, unfortunately I haven't been able to get the motor to sit properly in there because, as I say, it has been modified. But there's no reason why, if this wasn't a usual loco which had its mounting intact, there's no reason why I couldn't have put that back together again. Okay, so in summary, it does work to run a locomotive underwater, but to say the very least, it is quite a high risk activity because there's so much current going through the motor when you do it. However, there's not an awful lot of heat generated. It seems that the water seems to take away a lot of that heat and it keeps it cool, whereas if it was out in the open air, I think it would boil over and burn out a lot faster. However, when we started to drain the water away again, we saw that it did indeed get very, very hot, and that's when the damage seemed to occur. So in a way, if you're going to run a Loco underwater, if you've absolutely got to, run it underwater, but then don't run it out of the water again until you've had a chance to dismantle it completely and completely dry it, and perhaps that would improve things. So either way, that was quite interesting. We did find out something there, I think, about how motors react to water. So yeah, I hope you enjoyed that. This Loco isn't going to be running anytime soon. I think we've finally done it in, although of course the motor won't have been in great condition anyway because we've blasted it on 30 odd volts in the past. So there we go, hope you enjoyed that. Does a Loco work underwater? Yes, but it's certainly not recommended. Anyway, if you've got any other crazy engine challenges that you want me to try, do let me know down in the comments. But for now, thanks for watching and I will see you soon. Cheers everybody.